Oh hi, welcome to our medical and chemical change project. It's very good. We'll be explaining just that. And well, let's get started here. A compressed gas is easily combustible and is pretty well flammable. And a flammable material can catch on fire really easily. An oxidizer goes along, can play along in the combustion of other materials. And poisonous is just poisonous if ingested. And toxic is the same thing, if ingested, can do serious damage too. Biohazard is poisonous, can cause long-term effects. Corrosive can corrode away at material and stuff like that. And reactive is chemically unstable. That's all WEMA symbols. So.
So there's a solid which has a definite shape and definite volume. And there's a liquid which has no definite shape and definite volume. And there's gas which has no definite shape or definite volume.
Solid to gas is sublimation, gas to solid is deposition, liquid to solid is freezing, solid to liquid is melting, gas to liquid is condensation, liquid to gas is evaporation. There are two ways matter can change, physical and chemical. Physical changes consist of texture, color, and density. This is an example of chemical change.
So, matter goes into two categories, pure substances or mixtures. The pure substances turn into elements or compounds. Mixtures turn into either mechanical mixtures, solutions, suspensions, or colloids. The two changes that happen in matter, physical and chemical. A physical change in appearance or state of a substance. The composition of the substance stays the same, and an example would be melting. Chemical occurs when two or more substances react and create more substances. An example would be vinegar and baking soda reacting to make carbon dioxide.
Okay, go for it.
The difference between physical and chemical change is that chemical change ends up looking like something new, like a dyed shirt, while physical change only has a slightly different look to it, like when you melt ice with water. Walk past time one day. To change the state of matter, humans must change the pressure or temperature.
Oh, here there. Just reading the studies, as you can tell. Let's talk about them. Electrons. They're negatively charged and are found in the cloudy region of the nucleus. Protons are positively charged and are found in the nucleus. Neutrons have no charge and are found in the nucleus. Now let's talk about atoms. Atoms are the basic building blocks of all life. Of all matters, sorry. My studies said wrong. Molecules are at least two atoms held together by a chemical bond.
What are the different categories of elements? Metals. Metals are solids, and they are reactive. They are found in the gray-green arrow row. These also conduct electricity. Alkali metals are the most reactive out of all. Metalloids, these are found in the purple staircase of the periodic table. They are solids, but they are mixtures of gas, metal, noble gases. These are not typically reactive, but they are also found in the row 18. Some of these are helium, argon, and you might ask me, what is the mass number? And explain how you can figure it out. The mass number is the mass of protons plus the mass of neutrons. To find out the mass, round the atomic mass to the near whole number to find out what the mass number is. How does one calculate the number of neutrons in an element? So what you do is subtract the mass number from the atomic number. That's how you calculate the number of neutrons in an element. And finally, how do you find out how many electrons are in an element? It's just the number of electrons are equal.
Okay, let's go to my part. We're going to talk about molecular and ionic compounds. So chemical formula tells us what ions are found in a compound and the number of atoms in each ion, which is determined by the script number next to each element symbol. Okay, so an ion is an electrically charged atom. Ionic compounds are pure substances that are the result of a positive and a negative ion being attracted, or plural in that case. So, an ionic bond is a bond formed when positive and negative ions are attracted to each other. Some characteristics of an ionic compound are they are solid at room temperature and have a very high boiling point. Or melting point, I should say. Okay, so why would atoms lose or gain electrons? Atoms lose or gain charges to become more stable. Noble gases are the most stable family. Metals lose electrons and form positive ions called cations. Non-metals gain electrons and form negative ions called anions. The charge is found in the top right corner of the element symbol. So, a molecular compound is formed when two or more non-metals join together. It's created by sharing electrons, which is called a covalent bond. Some characteristics of a molecular compound are at any state. They can be at any state at room temperature. They do not conduct electricity in liquid. They have a very low melting point. So, the periodic table of elements is the building blocks of today's chemistry. It allows modern students to predict the outcome of chemical equations.
You're probably wondering about the definition of a chemical reaction. A chemical reaction is when two substances react together to make a new substance. Whoa! What was that? That was a chemical equation. A chemical equation is used to show a chemical reaction. This would be a product of a chemical equation. It is the final product or new substance between these two reactants. Two reactants are the things that go together to make this product. You could see as a chemical equation in two ways, with numbers and letters. Or you could write it as a word problem. There are such things as endothermic and exothermic reactions. Exothermic reactions are the ones that release energy. For example, light, heat, or other types of that. Endothermic reactions are the ones that absorb heat, or absorb energy, as I say. There are three ways oxygen can react with anything. There's combustion, corrosion, cellular respiration. There is a law that states that the total mass of reactants at the same mass of products as in all chemical equations. Mass of reactants is the same as the mass of products in all chemical equations. The matter is not destroyed, but merely rearranged. The person who came up with this theory was Antoine. Chemical reactions can happen in two systems, a closed system and an open system. For example, an open system would be an open beaker. A closed system would be a closed bowl or ball of some sort. There are four things that can affect a chemical reaction: the presence of a callus, the concentration of reactants, or the temperature of a system, or the surface area of the reactants.